Okay, so let's again come back to our famous picture. But I have now have different names for these protocol layers there. The layer that deals with sending the message on the LAN, I have named it as the link, right? So far I have not used that term, I have not used the term network to identify this other protocol running on top of that link here. So rather than calling it a MAC, I call it a link layer, and it contains all the protocols from the wires that deals with wires, as well as the MAC, right? Of course you need the protocol for the wires as well, right? Wires, or what we call the medium. How to connect them, what are the type of wires to be used, what are type of connectors to be used, all those things are there as well. And then in the MAC protocol, then we can have something like Aloha or some other protocol, right? So I lump them all together and call it the link. That deals with sending the message on that LAN, on that network segment. And the red part of the protocol is now named as the network. It's the network protocol, right? So when A wants to send a message to X, now the addresses are plugged into the message. Some entity on A create the data, and this addresses are plugged into that message by the network protocol of that machine, and it indicates the internet address of X and the internet address of A as the destination and the recipient and the sender, right? Then this frame is handed over to the link layer, and we ask it to A asks the link layer to send the message to R1. So the link layer would plug in this header, blue header, so and create the frame that travels on the network. So the frame created by the network layer is a frame, but we call it a packet, right? So the network layer creates a packet, and then it is like a frame, but we use a different terminology here. So this packet is contained in the frame, and the link layer would send it through the network, through the wire or the wireless medium, would send it to R1 interface of R. So it looks like the link layer of A is talking to link layer of R, right? Then the link layer of R would check the header, get rid of the header, and hand it over to the network layer of R. So ultimately what has happened is network layer of A is talking to the network layer of R. Link layer of A is talking to the link layer of R. Now this looks like the network layer is talking to the network layer of R, because when the network layer gets the message, this packet, it doesn't care about the link layer. So it's like it is talking directly to A, right? Then network layer again hand it over to the link layer of the green network. Green network plugs in, so that protocol plugs in the correct header, send it to the link layer of X, and finally it reaches X, right? So the network layer of A is talking to the network layer of X through R, but when X gets the message, it is like A is talking directly to X, right? Now there's a bit of a problem. We have not solved all the problems. We still have a problem. in a real, now we are sending a message from an IP address to an IP address. IP address of A to an IP address of X. Now consider take the example of your machine, your computer. It has an IP address, right? So you are getting messages from Zoom to that IP address. But on that machine, you are not running just Zoom, right? You are running Firefox. You may be running some other applications, right? So when that IP address is not enough to identify the final destination. Final destination is not the machine. IP address identifies the machine, not the correct way to say that. IP address actually identifies an interface, not a machine. But let's say it is a machine. So you can send a message from an IP address to an IP address through this, if we base this whole thing on the discussion so far. So sending a message from an IP address to another IP address is not enough, because the machine that contains that IP address, you may have hundreds of other programs running. You actually want to send a message from one program to another program, right? Firefox to Google search engine, or Google search engine to Firefox, not to a machine, right? So final destination is not an IP address. You need an IP address to identify the final destination in some way, but it is not the ultimate final destination. So we need some other mechanism to identify the final destination. Let's say that now we take this data part. To do that, we have to again exploit the data part of this. So we take the data part of this and put another addresses there. So now we can indicate the message is from a particular entity in A to a particular entity in X. First, you have to, of course, go to X to get this entity. So you still need the IP addresses, but ultimate point has to be identified. To identify that, you need another part for that address. So we call these addresses port numbers. They are the port numbers. So ultimately, a message is from a particular port number in IA to a particular port number in IX, not simply from IA to IX. It's not from IP address to an IP address. It's a port number running on the machine that contains that IP address. Sorry, a program running from in the machine that contains IP address of A to a program, one particular program running in machine X. So to identify that program, it's a loose way of, informal way of talking about port numbers, but let's say it indicates a program. So a program to a program. Ultimately, it's a single entity to an entity. So that to identify that particular entity, we need another form of addresses. We call that port numbers. So now we call this entity a transport endpoint, right? So there's ultimately a layer there in the machine A and machine X to put in this transport entity into our packet and create another header. So now it will ultimately identify the endpoint, right? So we should need this transport layer. So now the transport layer hands over the message to the network layer hands over the message to the link layer send it to the machine R. In the machine R, the link layer header is removed and hand it over to the network layer. Network layer looks at the message and figure out that it is not for itself, and again plug in the green part of the, send it to the green part of the network, and so on. But ultimately, message, when the network layer of machine X gets the message, it will get rid of the red header or the network header and hand it over to the transport layer. Then the transport layer checks and figure out what is the ultimate endpoint. So now it looks like the transport layer of A is directly talking to the transport layer of X. And by the way, there's no transport layer in R, because R is not interested in that. R get rid of, in R, it will get rid of the link layer header and checks the network header, but it won't go beyond that. So then after that, it plugs in another link layer header and put the message into the green network. So the R does not need the transport layer. So transport layer of A directly talks to the transport layer of X. We call it an end-to-end protocol. So one end to end, other. But our network protocol is a hop by hop protocol. Each hop, at each router, it will check the network header, but not the transport header. So the transport layer of A directly talks to transport layer of X, but the network layer of A talks to the network layer of X through R. So it has to go through R, right? Again, after that, this is not sufficient as well. Because this data part again needs some kind of format, right? Some entity on A has created the data part, and some entity on X is going to get it. So the both entities must agree on what is in the data part, what is the format, how do you interpret the bits, are they numbers, are they characters, right? Do they have a different structure, and so on. So to indicate that, you need another header there. No, there's another header. And that header is put on there by another layer, we call it the application. So it is also an end-to-end protocol. Application on A directly talks to application of X. So when the transport layer of X gets this packet, it gets rid of the transport header as well and hand it over data and the data application headers to the application, and application may also deal with the headers and some may present the data to you. I think this is good enough for the day. I'm going to stop it here.